Sine law. The sine law states that for triangle ABC, and this can be any triangle, it'll even work on a right angle triangle, but we're doing this for a non-right angle triangle. It says that the ratio of the length of side A over the sine of angle A is equal to the ratio of the length of side B over the sine of angle B is equal to, etc. And you can also flip this over. So this is the sine law. You're going to use this form to determine a side, and you're going to use this form to determine an angle. Now you'll notice what this needs, let's say we don't have this. So we have four quantities here, right? And one of them needs to be a known pair. I'm going to call this a known pair. That is, the length of a side and the measure of the angle opposite that side. If you have a known pair and then you have an unknown side, I want to find this, then I need that third thing, right? So if I have this angle, so if I have 3 of the 4 quantities, then I can solve for the 4th. Okay, now it won't do if I know angle A, side B, and side C, because I can't, if I pair these up, I'll have 2 unknowns. If I pair these 2 equations up, I'll have 2 unknowns, and if I pair these 2 up, I'll have 2 unknowns. So we need a known pair. To prove the sine law, we're going to construct an altitude AD. In triangle ABD, the sine of angle B is opposite over hypotenuse, which is h over c, and h is equal to, and I don't know why I've got the spinning wheel, so I'm going to pause. And the room has stopped spinning, so we get h is equal to c times the sine of b. If we look at the other triangle ACD, the sine of angle C is opposite over hypotenuse, which is h over b, and so h is equal to b sine c. Since h is the same, right, there is only one h in here, the height, we know that c sine b has to be equal to b sine c. And if we then divide both sides by sine b and sine c, sine b, sine c, sine b, sine c, these guys are going to cancel, and these guys are going to cancel, and we're left with c over sine c is equal to b, c over sine c is equal to b over sine b. If we drew the altitude from C and used similar steps, you would show that a over sine A is equal to b over sine b. Right? If we drew the altitude, it was kind of not nice looking, but we could do it. And therefore, we get the sine law. So that's the proof. To use the sine law to determine a missing side, oops, move the frame, we will use a over sine A equals b over sine b. We will need to know its side and its opposite angle, as well as the angle opposite the unknown side. So this is what we want to find, right? That's the unknown. So we need to know the other 3 things we need, and I'm going to call that a known pair. And then we've got another pair here. So that involves 4 quantities. We need to know 3 of them. And if we do, then we can find the 4th. To use the sine law to determine a missing angle, we're going to use this format. It really doesn't matter. It's just easier this way. Okay, so again, we have our known pair, and we have another pair, and in this case it's the angle we don't know. And, we'll just do a little rearranging, multiplying both sides by little b, and we'll be able to solve for the angle. Alright, solve for x rounded to the nearest hundredth. If you're given 2 angles, so here's our known pair, right? And this is the other angle. We can always figure out this angle, right? I mean, it's 60 degrees because we know that all three have to add to 180. So if you're given two angles and any one side, you can always use the sine law, because given two angles, you pretty much have all three angles. Okay, so let's set this up. So let's name this. This will be A. This will be little a. We'll call this B. This will be little b. We'll call this C, and that's little c. So the form that we want is little b over sine of angle B is equal to little a over sine of angle A, just based on the naming. I probably should have named these guys A, but it doesn't matter. So we substitute in x over sine 50 degrees is equal to 10 over sine 70 degrees. X will be equal to 10 times the sine of 50 degrees over the sine of 70 degrees. And make sure your calculator is in degree mode, right? You're going to have to set it that way after you clear it. And we plug that in, and we get x is equal to 8.15, because we're looking to the nearest hundredth. There are no units on this. There's no centimeters or anything, so this is just 8.15 units. In triangle POR, poor triangle, angle P and angle O and little r determine the perimeter of triangle PQR. Oh, really? PQR? So let's Q this out. Let's take a Q. PQR makes more sense than POR anyways. Anyways and any day. Okay, let's draw it. We don't need to be accurate. We just want to hold the information. So that's 63 degrees. This is 25 degrees. This is 12 centimeters. Little p, little q. Now you notice we do not have a known pair, right? But we have two angles, and so we know that angle R is equal to 180 minus 63 degrees minus 25 degrees. So angle R is 92 degrees. Just showing how poor a diagram you can draw. Okay, and this diagram really is just to hold information. We need to determine the perimeter, which means we need to find little p and little q, right? We need all three sides. So, using the sine law with p, q, and r, and finding a side, it's p over sine p is equal to r over sine r, okay? And use the known pair. Little p is r sine p over sine r. I just like doing that. And now I can substitute. So r is 12 times the sine of 63 degrees over the sine of 92 degrees. So p is equal to, if you're using your calculator, 10.69859559. Similarly, q over sine q is equal to r over sine r. Little q is r sine q over sine r. Little q is, okay, r, 12, sine of q, sine 25 degrees over sine 92 degrees. Q is equal to 5.074510396. Because remember, we don't round until the end, and now it is the end and we can round, so the perimeter is equal to p plus q plus r is equal to, remember that's 12, and rounded to the nearest tenth we get 27.8 centimeters, right? And there are units on here because we know that r is 12 centimeters. Okay, what's next? Solve the triangle. Solving the triangle means you have all three sides and all three angles, right? We have two sides. We have a known pair, and we have this. So the only thing we can solve for right now is angle A. That's little a, that's little c, that's little b. So we need to figure out little b, angle A, and angle B. So we're going to start with, we can't do anything with b because both of these are unknown. So this is the formula we're going to use. Sine A over little a is equal to sine C over little c. Now if I do a little rearrangement here, then I'm going to write sine A is equal to A times sine C over little c. And going one step further, A is the inverse sine of A times sine C over little c, which is, and now we can fill in numbers, right? Oops. Oh, that was a big eraser. So it's the sine inverse of, okay, so what do we got? Little a, 5 times sine 50 degrees divided by little c, which is 8. And this will take you there in one fell swoop, right? We will get right to angle A. And I'm actually going to show you a couple things. I'm going to pause and bring up a calculator. Wow, that took a long time. Okay, on mode. So make sure you are in degree mode and make sure your calculator is in degree mode. So what we can do is type second sine inverse. Now we want to enter the bracket. So 5 times sine 50, close bracket. Okay, make sure you close the bracket there, right? Divided by 8, close bracket, enter. And this takes us directly to, so A is equal to, it says round all answers to the finest tenth, nearest tenth. A is equal to 28.6 degrees. Now here's what might happen. Let's say you don't do the sine inverse thing, you just do this. So you just go, okay, I got 5 times sine 50, again, close bracket, divided by 8. What you're going to get is 0.4787, and you should recognize that this angle is unlikely to be 0.47 degrees, right? This will actually always come in as a number under 1, and you know, it's not likely any triangle we do is going to have an angle less than 1 degree. So if you get that, then you got to realize, oh, I don't have the angle, I have the sine of the angle, so do sine inverse of answer, and get your 28.6 degrees. At this point, angle B can be calculated, right? So we know that angle B is 180 degrees minus 50 degrees minus 28.6 degrees, right? And all I'm going to do is go 180 minus 50 minus, and I'm going to go second answer to just bring this number in, and hit enter, and we get 101.4 degrees. So angle B is 101.4 degrees, and we can now check 2 items off of our list, and the only thing we need to find now is side B. Now here's the thing. In order to find side B, we're going to have to use this calculated value, which means that we're not going to use 101.4. We're going to use the number that's in our calculator. All right, so let's set this up. B over sine B is equal to, and let's use the pair that we already know. Let's not use this calculated value. If we can avoid using a calculated value, we will. And we don't need to do 2 of them here. So B is C times sine B over sine C. B is equal to, little c is 8, times the sine of 101.39, right, over sine 50 degrees. So what's that going to look like in our calculator, right? That's the number we're going to use. So it's 8 times sine second function answer, right? That's going to bring in this number, divided by sine 50, enter, and little b is, I wrote too soon, 10.2. So 10.2 units, right? Because there are no units. This is not centimeters, so this will just be 10.2 units. And we have found the three quantities that we needed to, angle A, angle B, and, whoops, side little b. Moving on, number 4, determine the area of the triangle shown. Well, to get area, remember area is 1/2 base height. So we're going to need a height. And this will be the height. Area is 1/2 base height, and this will be the base. So, what do we need to find out? We need to find this height. And what do we know here? Well, if that's 70 degrees and that's 30 degrees, then we know that this is 80 degrees, right? I think anytime you're given two angles in a triangle, you might as well calculate the third. It could come in handy. So, can we get this directly? Well, I know 70 degrees. In order to get this, I'm going to need either this side or this side. If I use the 30-degree triangle to get h, I need either this side or this side. So we're going to need one of these two sides, right? And we're going to use the sine law. So forget the h right now. We're just going to take the whole triangle and use the sine law to solve for one of these two sides, and then use right triangle trig to get the other one. So let's go for this side here. What shall we call it? So seeing as I call that B for base, then let's call this A for not base, and call that C. So let's solve for little a. Little a over sine A is equal to, and this time our known quantities are B and sine B. So little a is B times sine of angle A over the sine of angle B. Okay, that's 10 times the sine of, okay, what's angle A is 70 degrees, times the sine of 70 degrees, divided by the sine of 80 degrees. Now remember, we're going to use this calculation later, so we're just going to keep it in our calculator. 10 sine 70 divided by sine 80, enter. You don't really need to close that. So 9.54, what was that again? 1888941. Check that. Yeah. Okay. So remember, we need to use this number, right? Because we are after this height, right? Area is 1/2 base height. We got the base. We need the height. This is a right angle triangle, right? So in a right angle triangle, sine theta is opposite over hypotenuse. Okay, what do we know? The sine of 30 degrees is h over little a, right? We have a. So h is equal to a times the sine of 30 degrees. So we go to our calculator, right? Just go times sine 30, which you already know is a half. And so h is 4.77094, and so on. Area is 1/2 base height, is 1/2 of 10 times this number, right? Again, no rounding until the end. So it's 1/2. I like to put fractions in brackets there. 1/2 times 10 times the number that's in there, second function answer. Hit enter, and that's our area, is 23. Rounded to the nearest tenth, 0.9 centimeters squared, right? If there was no centimeters, then you would write units squared, because an area has to be square something. And there we go, 23.9 square centimeters. What's next? Solve for x, rounded to the nearest tenth. So you might think back, and I think we did questions like this, and they were kind of complicated when you don't have the sine law, right? You would have had to, call this something, and call that y, and this is 10 plus y, and figure stuff out and all of that. But what do we want to do? We want to solve for x. So this is 90, this is 60, that's 150 degrees. That's 30 degrees. This is 90, that's 20, that's 110, makes this angle 70, so that's 40 degrees. And this whole angle here is 70 degrees. Now, what can we solve for? So let's take a look. Can we directly get x? In order to directly get x, we need to know, we need a known pair. So we got the 20 degrees, that can go with the x. We've got the 70 degrees, but we don't know this side, okay, so we can't use that. So we are going to have to do a two-part solution here, right? We're going to have to work something else out. All right, what's it gonna be? Oh, hang on a sec. You know what? That's not right. Hang on, that's 60. This is 120 degrees. 120, 140. Oh, that's right. That's 40. Never mind. You could have worked this angle out too, right? Does that help us, this 120 here? Yeah, actually, you know what? I think we need that because we've got this angle here is 10. I really want to get this side, okay? Because if I can get this side, then we can just use 20 degrees with opposite and hypotenuse. All right, so let's get this. What shall we call it? Actually, you know what? It's going to be this angle here. Let's not label. All right, here. Let's just call that y. So here's what we're going to do, right? We're going to say y over, here's the formula I'm using. A over sine A is equal to b over sine b. So y over sine 120 degrees is equal to, now what's our known pair, right? We got the 40 degrees and the 10. So we're going to go 10 over sine 40 degrees. So y is equal to 10 times the sine of 120 degrees over the sine of 40 degrees. 10 sine 120, make sure, close bracket there, right? Divided by sine 40, don't need to close bracket here because it's the end calculation. So y is 13.47296354729635. And so on. Okay, remember we're keeping that. We will round only the final answer. And now let's use this big right angle triangle. And so we will say sine theta. Okay, that's theta. That's opposite. That's hypotenuse. So sine theta is opposite over hypotenuse. The sine of 20 degrees is x over y, right? Y is the hypotenuse. So x is equal to y times the sine of the sine of 20 degrees. So this is y. So we just go times sine 20, enter, and we get x, which is 4.6, right, to the rounded 4.6 what? Meters. So there's x, 4.6 meters. Another two-part solve, right? But first we were working within this obtuse triangle, right? Big angle there. And then we could work within the large right angle triangle. And we needed this 60 to give us the 120, and we needed this 40. So we needed the 60 to give us the 30, and the 20 and the 90 to give us the 70 and the 40, etc., etc., or 120 and 20 and 40. But either way, work out all the angles. And we're done.